Okay, we're on this page. So yesterday we talked about how to solve these nonlinear systems using substitution. Today I'm going to go over how you use elimination. So in the future, you can kind of decide which method, just like when you were solving any system with like two variables, you can use substitution or elimination, just whatever maybe is easiest for you or whichever method you prefer. When we have two equations we're trying to use elimination, we can only do this if the exponents match. So like the problems that we even saw yesterday, even if I just scroll back up to this one really quick, this is what we ended with yesterday. I can't use elimination on a problem like this because my x's don't have the same exponent. Like the top one has an x squared and the bottom one doesn't. So if they don't have matching exponents, you can't use elimination on them. Because if you subtract, you're not going to have like right pieces together. Now on this next one, I can use elimination because I'm looking and I see that both my x's are squared and both of my y's are squared. So it allows me to be able to cross those off pretty quickly. What I would do, just like we did with a system of like linear equations, is try to get my variables to match but be opposite signs. So let's get rid of our y's. If I have a 2 and a 3 next to my y's there, what's the number that those can both become? 6. So what would I take the top times? -3. And then the bottom I would take times 2. Okay, and I like that we're doing opposite signs because I want them to be opposite when I'm eliminating them, so it's easier for me to just add. So remember, when you multiply everything by that number. So this now says -9x squared minus 6y squared, and then 35 times a -3 is -105. And then we take the bottom one times a 2. What does it say when you multiply it by a 2? Okay, let's add these together. Your y's should cancel. What do I have left for my x's? Okay, and then equals okay. How do we get rid of the negative in front of the x? Okay, so that would just become x squared equals 9, right? And then how do we get just x? Square root it. Now when you square root something, how many answers do we get? 2. So it's plus or minus 3. So make sure you think about that, because like yesterday when we were solving these, we had more than just one solution. So we're still going to have that today. So now I need to go back and solve for y. Now you go back to one of those original equations. It doesn't matter which one you guys want to go back into. I'm just going to go back into the top one. So I have to plug in a +3 and I have to plug in a -3. So for this top equation here, I'm going to put 3 times +3 squared plus 2y squared equals 35. And then we need to just start to simplify this. What would that 3 times 3 squared become? Okay, if I subtract that from 35, that should leave me with an 8. And then I would divide by 2. So I have y squared equals 4. What do I do now? Square root it. So what do I get for my y's? Okay, let's stop here for just a second. I got 2 x's, and now I put one of the x's in, and I got 2 y's. Okay, so there's going to be a lot of solutions here. When I put in a 3, I'm just going to write it over here, I got a +2 to come out, and when I put in a 3, I got a -2 to come out. I have not yet put the -3 in from up here. So I still need to do that. So that's what I'm going to do again. I'm going to use the same equation, but now instead of putting in a +3, I'm going to put in a -3. Would it be the same? Yeah, it's still going to come out to be the same number, isn't it? Because if you square something, Doesn't matter what the sign is, it's still going to be positive after you square it. So all the math is going to look the same for this. So we're still going to have y equals plus or minus 2. But now what my x value was a negative 3 instead. So it'd be negative 3, positive 2, negative 3, negative 2. And you can see on your page, that's what they have written at the very bottom. They have all 4 of those answers written down here. So we haven't seen one that had that many solutions yet. Yesterday, the ones that we did had like 2 solutions because only one of the equations had a squared. When they both have those exponents that are bigger than 1, you're opening it up for more possible solutions out there. So this is like those equations up above, those are both circles. So this is like 2 circles that are crossing. Like think about like a Venn diagram or something like that. They would intersect 4 times if you like kind of think about how those would cross. Okay. All right. Let's do another one. So let's turn our page over here. Still using elimination. Oh, hold on. Not using elimination on this one, I suppose, because they don't have matching exponents. So we will have to use substitution here. Okay. Let's solve the top equation for either x or y. I think it's easier to solve it for x because what would you need to do? You'd add the y over, so it would say x equals y plus 3. Where are we going to take this y plus 3? Plug it in on the second equation where? Wouldn't it go in for x? Because we're saying x equals. So now this is going to say y plus 3 and then minus 2 squared. Y plus 3 squared equals 4. Let's clean it up a little bit. So this first set would just become a y plus 1. You have a couple options if you want to try to solve this. One thing that you could do is because you have y plus 1 squared and y plus 3 squared is you could expand those out because you could like think about it's 2 of them and you could multiply them by using like your FOIL method. The other thing though that I'm seeing is since they all have squares and 4 is a perfect square, I might be able to square root everything and then have 2 different solutions at the end here. So if we square root everything, and the only reason why I would maybe do it this way is because that 4 is a perfect square. If it was like a number like 5, I would maybe go about it the other way where I'm like multiplying it all out. So this would say y plus 1 plus y plus 3 equals positive and negative 2. So I still have to think about there's 2 solutions that I'm going to get here. If I were to kind of split this off into 2 separate equations and I combine my terms, y plus y would be a 2y and then plus 4. We're going to set that equal to a positive 2 and we're going to set it equal to a negative 2. Because I'm still looking for 2 answers here. What would the y's come out to be? So 2 minus 4 would be negative 2, right? Divided by 2 would be negative 1. I think you're right, but it would be negative 3. Because you'd subtract the 4 and divide by 2 and you get negative 3. Okay, so those are my 2 possible y values, but now I got to plug those back in and try to find my x values. So I would just go back to your original, like up here maybe, or even this one. I would use the x equals y plus 3 because that's easier to think about. So if we plug in a negative 1, so if we do negative 1 plus 3, what's that x value going to be? 2. So that solution would be a 2 negative 1. Make sure you put it in the right order. X comes first. And then we would have a negative 3 going in for the y. What would that x come out to be? 0. How would we write that as a coordinate? Good. 0, negative 3. Very good. There's your two answers. Okay, we've got one more problem on the last page here. All right, they're saying on this problem here to find the length and the width of a rectangle whose perimeter is 20 feet and whose area is 21 feet. And they're giving us these formulas. Area is length times width. Perimeter is 2 times the length plus 2 times the width. Okay, so let's kind of think about what they're giving me up above in my problem. What do they tell me is the area of this shape? 21. So I'm just going to rewrite this as 21 equals LW. And what they say the perimeter was? 20. So I'm just plugging those pieces in. And now I want to solve for the L and the W because I'm trying to figure out like what my possible dimensions could be here. But again, because these are nonlinear systems, we could have more than one answer. There could be more than one way to create a rectangle that has the same perimeter and area as this. All right, so to do that, I would maybe solve one of the equations for one of the letters. To avoid dealing with like a fraction here, I think it might be easiest if we work with this formula and solve for either L or W. You could do that on the top one, but then you're going to have to divide by L or W, and you're going to have to work with that fraction 21 over L or over W. If you want to avoid the fraction, I would maybe suggest doing the other one. So let's take a pick here. Do we want to solve for L or for W? For W? All right, so I would subtract 2L first, so it'd be 20 minus 2L equals 2W. Then what would we do? We would divide by 2. So that would say 10 minus L equals W. Where do I take this piece? Yeah, plug it in up here. So 21 is now equal to L times 10 minus L. How would that simplify? Yeah, L squared. I see a squared, that means factoring is going to have to happen. Let's make that term, though, positive. Right now it's a negative L squared, so let's move the negative L squared and the 10L over to the left. So it would become positive L squared, a negative 10L, and a 21. The L's are the same as X's, so this is really X squared minus 20X, or minus 10X. Whoops, that should be plus 21. Thank you. Plus 21 equals 0. So what are two numbers that multiply to 21 and add to a negative 10? What'd someone say? 3 and 7. Are they both negative or both positive? Both negative. So what are my possible length dimensions? Okay, so now I need to find my width. I would maybe come back up here to this equation. 7 times what is 21? 3. So 1 would be like my length could be 7 feet, and my width could be 3 feet. What's the other possible combination? Opposite way around. Length could be 3 feet, width could be 7 feet. So you could have it either way. Now, they're really not too terribly different from each other. It'd be kind of more thinking about the position of the rectangle. Like think about portrait versus landscape, like on a photograph or something. That would be your possible change of dimensions. Any questions on that one? All right, that's it for notes there.